We're on video. I actually had them do the Pythagorean theorem, so you should do that real quick. See if you can get no decimals, no decimals. Then I'll show the trig. Anyone fill out their trig? Anyone start trying to do the trig after they find their numbers? All right. Hopefully that happens. Here we go. I'm going to go right to our first period's note sheet. Oh, look at all that good stuff. Okay, first thing. I heard someone say 45. Don't worry about that 2 root 5 over 5 thing. I'll do that in a minute. And I made this yesterday off of an old series of notes. So there's some space issues. So really try to squeeze in your next stuff there, though. But 6 squared and plus 3 squared is 45. And then 45 is 9 times 5, 3 root 5. Okay. Next one, I did not do the Pythagorean theorem because I recognize it as a Pythagorean triple. I think right now you should put these up in your paper, and hopefully you can remember these. First of all, 3, 4, 5 is the most popular. So if I saw a 3 and a 4 on the legs of a right triangle, then the hypotenuse must be 5. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. All right, so just doing some simple review, simple Pythagorean theorem kind of thing. All right, well, then the next one is 5, 12, 13. 12 squared is 144, 5 squared is 25. That adds up to 169. Square root of 169 is 13. So what that means is 5 squared plus 12 squared equals 13 squared. Done with that, 8, 15, 17, 7, 24, 25. Students don't normally remember those, but those with a high ability to memorize stuff, it's helpful. Then when you see these sides, you could, just figure out what they are without doing the Pythagorean theorem. So that's why the second one, I just got a 12. Third one, look at how I wrote this. I did it a little faster because I know it's going to be 21 squared plus a squared equals 27 squared, which ultimately you're going to take 27 squared minus 21. Realize I'm cutting myself off of the camera. I do like having the, that I'm presenting in class. All right, that ends up being 288, which is 144 times 2. Now, I do want to get radicals here because we're going to be obsessed with exact answers when we're doing trig. So we do like them in radical form. Guarantee the AP exam will love them as well. All right, so not really doing what we did yesterday, which was solving, hitting the buttons on the calculator for trig. You're just doing this now. You're just going to each triangle and assessing what would the trig of these angles be. And then it's all about the reference angle. So hopefully some groups got ahead. First hour did real well. After we got our radicals, I let them work. And but then I, little bit of corrections, some things we got to remember. So sine of A, pointing up here, if you can see, sine of A is opposite. Well, opposite is 6 over hypotenuse, which is that 3 root 5. So that's what sine of A is. And then off to the side, I did do a rationalization. Again, I was really obsessed with making this 2 pages. My spacing is really tough here. So I wrote 6 over 3 root 5. AP exam may not care if you rationalize that and reduce. I feel like I do have to teach it though. 6 over 3. I don't think that 2 root 5. Where's that for? Oh, that is for this. Okay. 6 over 3 root 5. Did I do that over here? That becomes 2 over root 5. All right. So the 6 over 3 becomes 2 over root 5. And then I showed off to the side for first hour. This is how you rationalize. You multiply top and bottom by root 5. I think we might have rationalized in August when we were in the PR section as a review concept. So that's how I get 2 root 5, and then this becomes 5 down here. So that's why I circled that over here next to the sine of A. So just the ability to rationalize is what we're practicing there. Then I went across, what's the cosine of A? Cosine is adjacent to A, 3 over that newly found 3 root 5. So there's where you see 3 over 3 root 5. And then I didn't rationalize because I figured it was a review concept. We know the 3's cancel. That's 1 over root 5. Then I multiply top and bottom by root 5 again. And then I get root 5 over 5 instead of 2 root 5 over 5. So just the ability to rationalize should be a review concept. Again, I think that's been kind of the problem this year, remembering old stuff so we can build on it. All right. That's why we're reviewing it. And then 6/3 for tangent of A, 6/3. All right. And then kind of getting the ball rolling here, it should fall into place. If you were able to do sine and cosine of A, sine of B and cosine of B, the same things happen. All right. For sine of B, I'm just only going to do this once to not over explain this. All right. Sine of B is opposite B, which is 3 over this newly found X, which is 3√5. All right. And I probably should put that as a simplified thing here. That ended up being 3√5. So 3 over 3√5. Well, we already did that. We did that for cosine of A. And then I did want to say something that you don't have to have memorized right now, but this is a thing. This is why this is occurring. Cosine of A and sine of B are equal because A and B are complements of each other. What does complement mean? What does that mean the angles add up to become, everyone? Second hour? Complement? 90. Why do I know it's 90? That's 90. And these two have to add up to 90 because the triangle has 180 degrees total. All right. So anyway, I know, hopefully the connection's there. So there is an identity that says sine of an angle equals cosine of its complement. I mean, it's really because of the sides just being flipped, who I put over what. So then the cosine of B should be the same as the sine of A, and it is. Question? I would say get used to it. Yes. We should not have had a problem with B. So yeah, the question was, should we be rationalizing? I would say yes. As a matter of fact, when I do the next stuff, definitely. Right. Hopefully you got that understood. And then yet again, the sine of C end up equaling the cosine of D because it just reverses the angle I'm looking at, but then it changes what sides are the reference angles, and then vice versa, C and D. Sine and cosine of C and D, respectively. Then tan of C is the flip of tan of D because I'm flipping the reference angle. So I'm flipping who's opposite and who's adjacent. Last but not least, this one's could be a little bit tougher. So this is 12√2 right here. Might be helpful to put it here. Right. And then this was just a random idea. I did something a little different than what the other teachers did, but you need to know how to work with radicals. You need to understand SOHCAHTOA, and it just puts them both together. Then we're going to move on from this. All right. So cosine of E or sine of E is 21/27. That's easy. Right. So, and then we should always reduce, but not so easy as cosine of E. Now we got that radical again. Cosine of E is adjacent over hypotenuse. Remember, adjacent's right next to. So what that ends up becoming is 12√2/27. Sorry for the spacing issues. And then that reduces. Should always reduce. So 3 goes into 12 4 times, 3 goes into 27 9 times. And the √2, some people were asking, where does that √2 go last hour? It just stays up in the numerator. Oh, man, we got a drink just popping open right now. Nice. All right. And then tan of E. This is where it gets bad. Tan of E is opposite 21 over adjacent 12√2. All right. So 21 over 12√2. Okay. So first of all, 21 over 12 is 7/4. Simple fraction reduction. And then what I squeezed in here in my brain was then rationalizing. That's how this 2 came here. Okay, so you rationalize this, and then you end up with 7√2/8. Okay? 7√2/8. All right, won't bore you with the rest of the details. Actually, the last ones don't really have to rationalize, but I did reduce. I knew there was reduction going on. So simple SOHCAHTOA, but maybe not so simple if we don't remember rationalizing. All right? I know in Math 2 honors, we do that probably September, October, for sure. Okay, now that's just review. Okay, so that was review from yesterday and review of rationalizing, so using SOHCAHTOA, and then review of Pythagorean theorem, which really should not be a big deal. Okay, now this is the new, but it's not all that new. Follow along with me if you could. All right, and I love look back there, that blue book. This comes out of that blue book, which I wish we were still teaching out of for our trig unit. Awesome, awesome thing. But just imagine you have a triangle that I have here that is equilateral. So 2, 2, 2, and then 60, 60, 60, of course. What our book does is derives the relationships of 30, 60, 90 triangles. So please follow along, really focus here. Just kind of went out the window last hour. People just lost connection, what was going on. I don't know why. All right. It really isn't that bad. What they decide is to drop an altitude. Right? So kind of draw that dotted line to understand the next picture. And then maybe get a pencil out or whatever, or a pen, and overwrite this so you could really see it, because it didn't really pick up real good. So of course so what I'm doing is cut this into two triangles. All right. And then there is a theorem that says when I drop an altitude and an isosceles wrong in an equilateral triangle, it bisects that opposite side. So those are ones, right? Pretty reasonable. But then also it changes these two angles, bisecting 60 to be a 30. So now what I have is a classic 60, 30, 90 right triangle. And what I'm about to show you next, there is a relationship. And I really want you to watch the first part, watch the next part, and then make a conjecture with me. So how do I find x? I use the Pythagorean theorem. And that's what they're denoting this as x there. Okay, so if you can't see that letter there, and I'm only picking the one on the left because it's the same as the one on the right. All right, and then what ends up happening is you get 2 squared, which is 4, 1 squared is 1, subtract, and you get root 3. So that's the answer. Now watch. This is the connection that did not happen last hour. What if I change these to any number? I'm going to make it even to make our lives easy. And I'm going to make it a little bit larger. No big deal. What if I made it 14? 14 and 14. So all I'm doing is making the triangle larger. Not a big deal. Okay, everyone. If this is 14, then what does the 1 become? 7. It ain't rocket science. It ain't a big deal. Let's do the Pythagorean theorem again. Okay, so now for the blue, it's 7 squared. I don't know if you could really do this on your notes, This is probably just for looking purposes, just to see what actually ends up happening. Oh boy, 4 times 4 is 16. I think 14 squared is 256. Does anyone know? Can someone actually put that on their calculator? 490, what is it? That wasn't even close. Oh my gosh, how embarrassing. We'll have to delete that from the video. All right. And then I subtract 49. Oh, let me try my math again. And I made an obnoxious number, but I know what's going to happen. 49. Oh gosh. 56, 45, 145. I'll have to delete that one as well. All right, so 147. Are we right? Which I know. Are you ready for this? This is crazy that I know this. I know because I know what happens with this, that 147 is 49 times 3. I know it. And it's actually true. Because you know what the square root of 49 is? What's the square root of 49? 7. So this is 7 root 3. Now look at that. When it was 1, that was 1 root 3. When that was 7, this is 7 root 3. What if I made this 18? Then what would this be? What would this be, everyone? 9. This is what was missed last hour. I don't know what happened. Then what do you think's going to happen here, everybody? 9 root 3. If this was 20, this would be 10. Guess what this would be? 10 root 3. This happens for all 30, 60, 90s. Got it? Lock it. So then this is what we actually do. We formulaize it. Whatever this is, we'll call A. Then this would be 2A. And therefore, this side would be A root 3. So A dictates everything. When this was 1, this was 2, this was 1 root 3. When this was 7, this was 14, this was 7 root 3. The conjecture's done. You either get it or you don't. All right, we're going to move on. I know I teach that way, but I expect things. I expect that we know how to do a denominator rationalization, know how to do the Pythagorean theorem, blah, 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 blah. Now, draw a line in the sand. This is a different one. This is a 45, 45, 90. Okay, so 1, 1. Why? Why are these both 1s? Because this is an anyone isosceles. Okay, which I think that's a great name for a kid. Don't you think? Isosceles Samuelus. Oh, I almost wanted to adopt a kid just to have that name. I couldn't get that past my wife. She didn't want one of the daughters called Isosceles. Doesn't it feel like a male? We can't get into that. Okay, what's 1 squared 1? What's 1 squared 1? 2. Hey, what's the answer then for x? Square root of 2. You want to get nuts? Let's make these, pick a number. 5. Ooh, an odd number. How mean. Okay, so 5 squared plus 5 squared equals x squared. What's 5 squared? What's 25 plus 25? What's 50? A number? 50 is 25 times 2. What do we end up with then? 5 root 2. Watch this. I'm just going to stick a 5 in front of that root 2. What if I made this 38? Then this would be 38. What would that be? 38 what? Root 2. So we're going to formalize it. Every 45, 45, 90, if this is A because they're isosceles, and this shall be A root 2 always. These are completely two different scenarios because 30, 60, 90 is not even isosceles. All right? Okay, now I don't know how to do this with the video making. Maybe I'll stop the video and then continue this with third hour. But I want you to fill in those missing parts. I want you to understand, first of all, I start with the 45, 45, 90. And then I want you to fill in these missing parts. And then we can do the trig after. And I might, just for pain purposes, get the conjecture I was trying to get when I was dealing with the other class. Because it got a little hairy with the whole rationalization and all that other stuff. You know what? Maybe I'll just leave. I don't know if I can edit the video or not and cut out some parts. I'll see if I can. I'll cut this part out, but I'm going to walk around class. I really don't know how to stop the video. I guess I could check. Okay, but that's what you're doing. You're filling in the missing parts through the relationship that you know. Oh, I can't pause. I can stop sharing. I get a little nervous about how I can put two things together. I'm just going to do it. All right, great. Okay, so some people are done with the first 3. 9. Okay, got that one right. Some are tough. The second 2 are tough. So when you go to this right here, one thing I walk around with my headphones. I think what's this? The yellow thing. Here though. So you guys got this one right? I walked around wondering what's X and Y in this one. Come on. A root 2 is a 3. Here's the problem. What side is this supposed to be? Is it the A or the A root 2 side? That A root 2 equal to that cell. That A root 2 equal to that cell. That's how you do that. And then this one right here. Oh, this is A root 2. So we get this one, then you take this and multiply by this 2. And then I'll go over to the other. Okay, go back to the video and go calculator. You can have decimals. No decimals. Or as what's it called? Incredible speed decimals. Then have to be decimals. And actually, an incredible speed, you can go for math is math. Everything, no matter what. No? You know that? You keep waiting about time before. I never do that. Why? Oh no. Okay, hey, let's show the 45s real quick. I'll show the 45s and then go to the 30, 60, 90s. And don't do the trig yet. The trig gets a little hairy. Okay, here's the 45s. All right, this is what you should have got. Who got B? Anyone get B right? 13 root 2. Nice. I did see someone get C right. Okay, this is what we're talking about here. Okay, so first one's easy. 3, 3, 3 root 2, the old A root 2 connection. But the second one's hard. You're supposed to set A root 2 equal to 26, divide by root 2, and then rationalize. And you do want to rationalize because then it becomes 13 root 2, which is what the other two sides are. So someone asked, do we have to rationalize? Sometimes you really should because it does end up looking nice. All right, how many people got C? C, 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 C. All right, I feel like more people should get that C from my hints. I told them for C, the 45-degree side's 5 root 2. That's supposed to be A. So to get the hypotenuse, I need to multiply that by root 2. And there's the math for that. Did I do that? Oh, I cut it off. 5 root 2 times root 2. Root 2 times root 2 is 2. 2 times 5 is 10. All right. Now go to the 30, 60, 90 side. So I should hear your papers flip and fill in these missing parts. Some are easy. Some are not. Okay, and then I'll walk around. Triangle. You know, what side should be what? I'll start writing from the trig in, then I'm going to go to what you should do in two up. Yep. Maybe you 36, 90, now I stop. Oh, wait, right. So here's a discussion over here. I'll put this on the video. Here's a discussion from this great crew over here that the hypotenuse is always the biggest side. So the hypotenuse is 2a. Some people screw up who is what side. A root 3 is smaller than 2a. All right, so the side opposite the 60 is the second largest side. So that's, here, I'll write this down as we go. Side opposite the 30 is the smallest side. So that is just A. Side opposite the 90 is 2A, because 2A is larger than A root 3. 2 is root 4. So that's what you should be doing in all three of these and then trying to figure out what happens from there. Okay, first one should be easy. What's X? No. What's, yes, sorry, my bad, dog. I thought this was X over here. So 36. What's Y? What's Y? 18 root 3. So I'll slide down to those and show those answers. Okay, so different formula. Then I put opposite adjacent hypotenuse when I started doing the trig, which I didn't want you to do yet. All right, next one. How many people got this one right? 5 or 3 and 5. Anyone? Okay, so that one's not hard either, sorry, because 10 is the hypotenuse, which is the 2A side. So again, every 30, 60, 90 is proportional. So it holds these values true. A root 3, 2A for 30, 60, and 90 sides. All right, so then that means X go backwards as 5 root 3. Now, hopefully more people got the next one right because it was the same thing you had to do on the previous page. Unfortunately, the 60-degree side is given, which is supposed to be the A root 3 side. So how do you find out what the other sides are? You literally set that equal. So the A root 3 is 12. You set it equal to A root 3. And yes, you are going to want to rationalize. All right. And then, yeah, I couldn't, just thinking about something last hour and it does work out well. But that becomes then A, which is the 30-degree side. So that's 4 root 3. Now the Y is double that because that's the 2A side. So that's why we get 8 root 3 there. All right. Now let's go back up here. Now that you got your labels, try a couple trig things and I'll walk around. And then I'll tell you what you should come up with here, but we are running short on time a little bit. So try doing the sine, cosine, and tangent of 45 with the sides that you have given, and then notice a relationship. And I think I'm just going to shove the answers in your face after I see how many people successfully do that. By the way, not that you care, but I ignored secant, cosecant, and cotangent for right now, just to get these down. Then we can talk about those later. I don't know, you're totally in a different world. And oh no, what you thought? Get sine, cosine, and tangent. Are you for one of them? Huh? This is the connection I want you to make, right? I know I think I go with the bond is that some are done, some are happy with them, some are leaving off. So they just add them all to. Some people touching the calculator when I told them not to. Your finger should burn right off if you're touching that calculator. Okay, so let's do this a little different here than the first hour. Boom. Okay, so now you see all this crap here for this. Here's what should have happened. I'll show you the first one. Did you get root 2 over 2? How many people got root 2 over 2, root 2 over 2, and 1 across the board for the first one? right? Because the first one is sine is opposite over a hypotenuse, sorry. And that would be A is 3. So I picked this 45. Hopefully you can see me here. So it's 3 over 3 root 2. The 3's cancel. And then you have 1 over root 2. And I think I had that somewhere where I rationalized. Did I write that somewhere? No, I guess I did not. But, I kind of assumed that you knew how to rationalize at that point. 1 over root 2. I guess I could write this over here. So when the 3's cancel, I'll do this for movie purposes, it becomes 1 over root 2. And then you have to rationalize. So sorry for my spacing. That's how you get root 2 over root 4, which is 2. All right? And then same thing happens for cosine of 45 because the adjacent and the opposite sides are equal. So I get the same thing. And then tangent's really easy. You just get 3 over 3, which is 1. And I cut that off for the final answer. And then lo and behold, this was the connection I wanted you to make. You go to the next one, which this is 13 root 2 for the adjacent and the opposite sides. So when I do sine of 45 in that triangle, I get 13 root 2 over 26. Feel free to write that down once. 13 over 26 is 1 over 2. I get the same answer. Well, it really is the same question, just a different looking triangle. I want you to understand that this is always going to happen. This was the connection. Doesn't matter what the sides are in a 45, 45, 90, the same trig things are going to happen. For the tan of 45, these guys always talking over here. The group I just, all right, 13 root 2 over 13 root 2 ends up being 1 again. Right, and then the last one, we get the connection. Okay, I get it. I take the last values in that triangle, I reduce, I rationalize, whatever. I should get root 2 over 2. Your homework should be easy. It would be smart, though, maybe do one more connection when you find all the sides, then do the trig. Try it one time to reduce and rationalize and see that you get these values. All right, go ahead and try the 30, 60, 90 in our last 5 minutes, even though we have 10. So try to do a couple trigs on the 30, 60, 90s. Similar triangle. Once you get the first set of the answers, you kind of count them to the next set and the next set. So we'll see that about 2 more minutes until 9:23. Maybe it's a work problem that then just because of time. You are going to specifically break this. You have to have these things memorized. You're going to have to go sine of 45 and root 2 over 2, like right away. And the 45, 1, right away. You have to memorize. We're going to deal with them so much that they sunk into the brain. Just lock in. Getting a little jumpy. It's 22, 922. I said 924, so we. wish you would have went across on one plus. But this one goes above it, and it really is terrible. So anything terrible. We're running short on time, and I'm worried that even if I waited till 24, we'd be running out. So here we go. Just shove the answers in your face. Take a look up here, but hopefully at least succeeded on a couple of them. So I went across on the first one. Okay, so on the first triangle, 18 over 36 is what? 1/2. Okay. And then for cosine, it was 18 root 3 over. Did you at least do that, right? Okay, so I guess I didn't. Did I cover all these side measures first of all? Sorry, I probably didn't do that. Did I? I can't remember. I did. Okay, wow. Woo! All right. Remember my math earlier too? Okay, so then that ends up being, sorry for the spacing. I really should have spaced this out better. But that ends up being 1 root 3 over 2. Okay, and how many people got that? That shouldn't have been that hard. And then the last one, probably not so great, maybe, but hopefully you learned how to rationalize. So the two sides over each other are 18 over 18 root 3. The 18s cancel to be 1 over root 3. And then at this point, we should start being able to rationalize. Now, someone asked, do we always have to rationalize? I think you better get used to it because sometimes it gives a good answer that looks nice. This one, yeah. But really, tan of 30 root 3 over 3 is something you're going to have to lock in. You're going to do this so many times, this trig on 30s and 60s and 45s, that hopefully it does get memorized. Those in math 2 honors last year, you know that's what it was all about. And then when I went to 60 in the same triangles, you dealt with the same, numbers. And then look at what I did. I just remembered from the previous one, cosine of 30 should equal sine of 60 because I'm reversing the angle, the reference angle, so that changes who's adjacent, not opposite. So sine of a 60 equals cosine of a 30. I think I could fill that in. And then cosine of a 60 equals sine of a 30. So that's how I got 1/2. And then tan of 60 is flipping this fraction because it flips who's opposite and who's adjacent. So that ends up being 18 over root 3 over 18, which is root 3. The 18s cancel and you just get root 3. Okay, and now because of time, we're at 5 minutes. The same thing should have happened in the other triangles. If you got that far, the second triangle, sine of 30 gave you 5 over 10, which is 1/2. Cosine of 30 gave you 5 root 3 over 10, which is root 3 over 2. Tan of 30, okay, I get it from the 45 thing. I'm going to get the same answers no matter what happens as long as I get those sides identified. And then, of course, this is going to happen. All right. And then the last one, I get it. I did do one of them. Sine of that 30 in the third triangle gave me 4 root 3 over 8 root 3. The root 3's cancel. 4 over 8 is 1/2. So all of these are the same. All right. And that was the conjecture there that we were supposed to get out of this. 1/2, root 3 over 2, root 3 over 3, root 3 over 2, 1/2, root 3. Okay? All right. I didn't get to these in the other class. We got the homework on the next 2 pages. I swear to dog, this should go really fast. I actually reduced the amount of trig in each question, gave you better spacing, and then I have a little challenge at the end there. I love that question. All righty, let's stop it.